Hey there, I'm Tony with Fieldpiece, and in this training course, I'll demonstrate 3 common vacuum setups used in the field and help you understand the nuances of each one. Along the way, we'll cover best practices for system evacuation, from testing your vacuum pump all the way to the Decay test. All this to help you do your job easier, faster, and better. Before starting any system evacuation, it's a good idea to check the condition of the oil in your pump. Now to do that quickly, you can perform an ultimate vacuum test. Now you can do that by taking your Micron gauge and connect it directly to the 1/4-inch port on your vacuum pump. Now make sure your other ports are capped off and turn on your pump. Now every pump has a Micron value for their ultimate vacuum spec. So in this test, your pump should be able to hit that Micron value within 30 seconds or less. For the Fieldpiece pumps, that value is 15 microns. And as you can see, we're quickly reaching that 15 micron value, which is an indication to me that the vacuum pump is ready to pull a vacuum. Now the key to any system evacuation is to maximize your flow wherever you can by removing restrictions. Now one of the easiest ways to do that is by removing the Schrader valves. Now since I have a pump down system here, I only need to use the capture rod to take out the Schrader valves. Now, once I have the Schrader valves removed, I will install the valve core removal tools onto the Schrader valves in preparation for my evacuation. Now, if the system was pressurized, the sight glass on the Fieldpiece valve core removal tools make it extremely easy because you can visually confirm that you've captured the Schrader valve before you have to blank off the valve core removal tool and play the game of, did I get it? Now I'm ready to pull a vacuum on the system. Now the first setup we got going here is a single hose direct connection from the vacuum pump to the equipment. Now in order to maximize the flow, we're using a larger diameter 3/8 inch vacuum rated hose with a 3/8 inch connection at the pump and a 1/4 inch connection on the valve core removal tool on the suction line. And on the complete opposite side of the system, we have the vacuum gauge connected to the side port of the VCRT at the liquid line. Now for a proper setup, you want to make sure that the ball valve connected to the vacuum gauge is open so we can read the pressure in microns, and you want the primary ball valve closed to trap the vacuum. And on the suction line, you want to make sure that the ball valve is open to the vacuum pump. It's always good practice to utilize the gas ballast when putting a vacuum on the system. Now in order to do that with your pump, you want to start with your gas ballast in the closed position. Fire on your pump and then open your gas ballast. Now what this does is that this allows a lot of the moisture and non-condensables that are coming out of the system to exhaust out of the pump rather than settle into the vacuum pump oil, thus contaminating it and making your vacuum jobs just take a lot longer. Now, once your micron level gets to about 2,000 or 3,000 microns, most of the moisture has been removed and you can go ahead and close your gas ballast. In case you forgot it was open, you have a blinking yellow light here to remind you that it's open. Now with your gas ballast closed, you can proceed to get to your target micron value. Now what that value is, you always want to defer to the manufacturer's specification in the manual. And for best practice, you want to make sure you're reading your microns with your vacuum gauge as far away from the pump as you can. Now with this single hose setup, it's very easy because we're pulling a vacuum on the suction line and we're reading the microns on the complete other side of the system at the liquid line. Now the benefit of that is that whatever pressure reading I'm getting at the furthest end of the system is the highest. In other words, the pressure everywhere else in the system is going to be lower than the value that I see on my vacuum gauge. So that's a real plus. Now, with the Job Link app, you have the ability to get a visual representation of your evacuation with trending. Now, as far as whatever target value you're trying to get there, again, refer to the manufacturer recommendation. But once you hit that target value, you're going to want to ensure that you have removed all the moisture and the non-condensables by performing a decay test. Now, in order to perform a decay test with this setup, it's very easy. All we need to do is isolate the vacuum pump from the equipment. Now, I'm going to do that by blanking off this ball valve here. However, pro tip, before you blank it off completely, close the ball valve about halfway to allow any trapped air or moisture in the ball valve to get sucked out by the vacuum pump before you go ahead and close it fully. Now, once you've isolated it with the ball valve shut, you can turn off your vacuum pump and now view your decay. So what you're looking for is, if you see your micron values instantly shoot up really, really fast and never settle out, that's an indication that you have a leak. Or if you see your micron values kind of shoot up into the thousands and then begin to settle out, well, that's an indication that you still have moisture left in the system and you need to either continue your evacuation or flow some nitrogen through there to get some of that excess moisture out. However, if you see, like in this scenario here, where your microns are pretty much holding at where you left it, that's a good indication that all the moisture non-condensables have been removed and that you've pulled a good vacuum. Again, when it comes down to the target microns you're trying to hit and the decay test, always refer to the manufacturer's specification. So back to the setup. The single hose direct connection from the vacuum pump to the equipment is the simplest of the three setups that we're going to cover today. It reduces the number of connections and tools you need to pull a vacuum on the system. Now, if you're looking for even more speed, let me show you how in the next setup. The second setup we have here is a two-hose direct connection from the vacuum pump to the equipment. Very similar to our single hose setup we covered previously, with the addition of a second vacuum-rated 3/8 inch hose from the vacuum pump to the high side of the system. Now with this setup, you want to make sure that you have both the low side and the high side ball valves open to the vacuum pump, and of course the ball valve to the vacuum gauge to read the microns. At this point, you're ready to go ahead, fire on your vacuum pump, and open up your gas ballast. Now the benefit of a two-hose setup is that you're pulling vacuum from both ends of the system at the same time, which should help you reach your target value faster, especially on larger equipment. Now, one thing to keep in mind with the two-hose setup when looking at your microns is that whether you have your vacuum gauge on the high side like I have here or the low side, we're now measuring microns on the front end of the system and not the back end like we were with the single-hose setup. So what does that mean? That means that the micron numbers you see here are actually going to be lower than what's going on in the system, which might lead you to believe that you've hit your micron target in the system, but you really haven't. So you're going to want to let your micron values get under your target when reading from the front right here. But here's a pro tip on how to check that the rest of the equipment has reached the proper vacuum. Go ahead and close the ball valve here, thus isolating this side of the vacuum pump. Now you could expect the micron readings to jump up some because we've changed the position of this micron gauge from the front end to the back end of the equipment. Now we're just pulling vacuum through one end, and once you've hit the micron value that you're looking for on your micron gauge, now you're confident that the entire system has hit that micron gauge or has hit that micron level, and go ahead and blank off the other side of the vacuum pump, turn off your pump, and perform your decay test. The benefits of the two-hose setup are slightly faster evacuation times on smaller equipment, but significant speed boosts on medium to larger pieces of equipment. Now, when pulling vacuum on both ends of the system, always consider the position of your vacuum gauge when reading your microns, and position the vacuum gauge in the back to make sure you're taking the most confident micron readings on the system. The third and final setup we'll cover is pulling vacuum through the SMAN digital manifold. Now I know some of you may balk at hearing that, but there are many technicians that pull vacuum through their manifold every day. And my intent is to ensure that for you that do pull vacuum with your SMAN digital manifold, you understand some of the nuances involved and how to properly use the built-in micron gauge in the SMAN manifold. Now this is the proper way to set up using your SMAN digital manifold to pull vacuum. Now what we have here is we have a 3/8 inch vacuum rated hose from the vacuum pump to the 3/8 inch vacuum port on the manifold block. And we have two 1/4 inch hoses leaving the manifold block and connected to both the high side and the low side. Pro tip, I like to remove the Schrader depressors on these 1/4-inch valves just to remove a little bit of the restriction there because they're not needed at the end of the valve core removal tool. Now, in order to set up the block properly to pull vacuum, you want to make sure that both your low side and your high side knobs are open, your vacuum port is open, and your refrigerant port is closed. Now with this configuration, you're ready to fire up your vacuum pump and start to pull vacuum. Now that we're pulling vacuum on the system, a couple things to understand on the screen. Once it gets into a deep enough negative pressure, the SMAN digital manifold will automatically change the display into vacuum mode. And in vacuum mode, you'll see your Micron, your live Micron readings in the top left. Under that, you'll see a rate of change, how fast are the Microns changing per minute. And you'll get the rate indicator here. So more bars you see to the left of this center point means that you're decreasing microns, and the more that you see, the faster it's decreasing. If you see little boxes light up on the right, that means your microns are increasing. This is useful in when you're in that blind zone between atmosphere and when the gauge begins to show micron readings, that you're actually decreasing in microns and not just spinning your wheels waiting for something to happen when it's actually not. So that's how you understand the screen on the SMAN digital manifold when pulling vacuum. Now, in order to best use the vacuum gauge built into the SMAN digital manifold, you need to understand that since it is built into the manifold, it's closer to the pump, meaning that your micron value here is going to be lower than the micron value in the equipment. So when using the built-in vacuum gauge, you're going to want to make sure that your microns get below the target value that you're looking for in the system. So for example, let's say that my target value is 500. Right now I'm reading 280 at the manifold. I can check to see if the equipment is at the appropriate level by isolating the vacuum pump, closing the vac knob here, and letting the pressure stabilize at the sensor, in these hoses, and within the system. Now be sure that you keep both the low and high side valves open. If you close those during this test, you're just trapping the sensor inside of the block and just reading the microns that's in there, which does you no good. So in this test, if your micron levels pass decay, then you can feel pretty confident that you pulled the proper vacuum in the system. Now, if your levels rise to above what a decay test would allow, then you would need to either open up and continue pulling your vacuum to a lower micron level here, or if it was due to moisture, you might want to pause and flow some nitrogen to get the excess moisture out of the system. Now, to get a better representation of the micron levels inside the equipment, here's a pro tip. Add the MG44 dedicated vacuum gauge to your setup by connecting it to the high side or the low side VCRT at the side port. Now we get a micron reading at the front end of the equipment, which is further away from the vacuum pump than the SMAN digital manifold. So you will see a pressure difference. Now, one thing to note is as you get into deeper and deeper vacuum, that pressure difference is going to get smaller and smaller, and that's okay. The one thing to consider is, just like in our 2-hose setup last time, we are measuring vacuum at the front end of the equipment. So we're going to apply that pro tip from the last setup here again. We're going to close this ball valve at the vacuum gauge, essentially cutting off the vacuum to one side of the system and repositioning this measurement at the back end of the system, which is at the highest pressure. So once our micron readings here have reached our target value, we're confident that the micron readings throughout the rest of the equipment are at or below that target value, at which point you can go ahead and blink off the other VCRT, isolating the vacuum pump to begin your decay test to ensure that all moisture and non-condensables were evacuated from the system. An additional benefit of using the MG44 with the SMAN is that when you do blank off at the VCRTs, you get a faster, more accurate representation of the decay because you've removed the hoses from the test. Plus, you can view the Micron measurements from the MG44 on the larger display of the SMAN. Let me show you how. First, confirm that wireless is enabled on both tools. On the SMAN, press Menu, and Enable Wireless, press Select, wireless is on. On the MG44, go to Menu, Start Wireless, press Enter, and wireless is on. Now on the SMAN, press Link Tool and confirm search. Now the SMAN will look for any wireless tools that are powered on and within range. Now when the 4-digit code of your MG44 shows on the screen, in this case, I'm looking for 2544, you can confirm that by pressing Select, and now I see the wireless signal bars from the vacuum gauge confirming that I'm viewing the Micron readings from the MG44 on the larger display of the SMAN. And there you have it. In this training course, we cover 3 common setups to pull vacuum used in the field: single hose direct connection, 2 hose direct connection, and pull vacuum through your SMAN digital manifold. You also learn how to test the vacuum pump and the vacuum pump oil, and what to look for in your decay test. Now always remember, where you measure your microns has a big impact to ensure that you removed all moisture and non-condensables from the system. For more information, go to fieldpiece.com. Follow us on social media at Fieldpiece Products, and as always, stay tuned for more videos.